Okay, we're moving on to exercise 3.3, which deals with division of complex numbers. We start out by looking at the case where you have your divisor is a real number, in this case 2. It's easy enough. All you've got to do is take the 2 divided by the 2, and then you take the imaginary part, the 5i, divided by 2, and you end up with 2 over 2 is 1 plus 5 over 2 times I. Now, when the divisor, or the thing at the bottom, is a complex number, it's a little bit more tricky. So what we need to do is consider what we call the conjugate of a complex number. And it's shown below. So let's say our complex number z is equal to 1 plus 3i. Then its conjugate is, it's denoted z bar, and it's 1 minus 3i. So all you do is you take the imaginary part and you change its sign. If that were a minus, it would become a plus. If it's a plus, it becomes a minus, and so on. And this one here is called the conjugate, again denoted z bar. So let's look at how we use this when we're dividing by a complex number, as we are in this example here. Now what we do is we multiply above and below by the conjugate of the denominator. And we do that in order to get rid of the complex number in the denominator. And here's how it works. Okay, so we're taking 3 plus 4i over 2 minus 5i. We need to simplify this. So what we do is we multiply above and below by the conjugate of the denominator. Now, if the denominator is 2 minus 5i, its conjugate is 2 plus 5i. And in order not to change the fraction, we have to multiply above and below by the same thing. Then what we do is we multiply top by top, so you get 3 plus 4i needs to be multiplied by 2 plus 5i, and bottom by bottom. So you have 2 minus 5i needing to be multiplied by 2 plus 5i. Now we can split the bracket on top. We're going to go 3 times, multiply with the second bracket, 2 plus 5i plus 4i times 2 plus 5i. And we're going to do the same for the denominator. You have 2 times 2 plus 5i, so I'm splitting the first bracket, minus 5i times 2 plus 5i. Multiplying out the top using rainbows, you have 6 plus 15i plus 8 plus 20i squared. At the bottom you have 4 plus 10i minus 10i minus 25i squared. And that is equal to okay, I'm going to add the 6 and the 8, so you get 14 plus 15i. Now, I squared is equal to minus 1 times 20 is a minus 20. And I'm going to do the same here. Okay, so it's 4. So, see these two? These are cancelling. And then you've got to just evaluate this bit here, so minus 25. Now, I squared is minus 1. So you have minus 25 times minus 1 on the denominator. Now again, on the numerator, on the top, you've got a 14 minus 20, so it's minus 6. And then you've still got your plus 15i. And on the denominator, you have 4 minus gives you a plus 25. So you end up with minus 6 plus 15i over 29. Again, if you want to split that, you can. And that's your answer. Now you notice that there are no complex numbers anymore in the denominator. Now I'll just show you a quick shortcut for that little operation. I'll just take this as an aside over here. just over here. Now look at the denominator, okay? It's as if I have x minus y times x plus y, okay? And we know that when you multiply those two things out, you get x squared minus y squared, the difference of two squares. Now, we can use this rule to do a shortcut on the denominator, okay? So in other words, you have like 2 minus 5i times 2 plus 5i. And the answer is equal to, the first thing to be squared is a 4, minus the second thing to be squared is minus 25i squared. Now we know I squared is minus 1 times minus 25 is a plus 25, so it's 4 plus 25, which is equal to 29. And we can do that as a shortcut to work out the bottom without having to split up our brackets and so on. And again, you'll notice that, you know, the whole reason to multiply by the conjugate is for this cancellation of the i's ending up just with an ordinary real number, the denominator. Now again, staying on the subject of conjugates, we have a complex number z equal to 2 plus 6i, and we have to express the following in the form a plus ib, which is in complex number form. Okay, so you're asked to multiply z by its conjugate. Okay, so the dot here means multiplication. So what we do is z is equal to 2 plus 6i, and its conjugate is 2 minus 6i. And again, I'm going to go the long way of doing it. I'm going to split the bracket, plus 6i times 2 minus 6i, and that's equal to 4 minus 12i plus 12i minus 36i squared. Now the minus and the plus cancel, and you end up with a 4 minus 36 times I squared is minus 1, and it's equal to 4 plus 36, which is 40. And that's the answer. Okay, the next one we're asked to do is z plus z bar. So that would be z is 2 plus 6i plus z bar is 2 minus 6i. And that's simply equal to, you add your real parts together, 2 plus 2 is a 4, 6i minus 6i is 0. So your answer is simply 4. Okay, next example says that z1 is this, 2 plus 3i, z2 is minus 1 minus 5i, and you have to find the conjugate of when you add the two together. Now it's important that you add them first, and whatever answer you get, you then get the conjugate. Okay? So we'll add them first. z1 plus z2 is equal to 2 plus 3i plus minus 1 minus 5i. Adding the real parts, you have 2 minus 1 is a 1. 3i minus 5i is a minus 2i. And that is equal to z1 plus z2. But we want z1 plus z2 bar, the conjugate of the answer. And you simply take the complex number and change the sign of the imaginary part. So it becomes 1 plus 2i. And that's the answer there. Alright, the next one asks, is z1 plus z2 bar equal to z1 bar plus z2 bar? So in other words, if you add them and then get the conjugate, is it equal to getting the conjugate of z1 and adding it to the conjugate of z2? Now we know from up here, z1 plus z2 is 2 plus I, so we get then z1 bar. Now z1 is 2 plus 3i, so z1 bar is 2 minus 3i. And z2 is equal to minus 1 minus 5i, so z2 bar is minus 1 plus 5i. And we want to add these two things together. z1 bar plus z2 bar is equal to 2 minus 3i plus minus 1 plus 5i. 2 minus 1 is 1, minus 3 plus 5 is a plus 2i. And is that equal to z1 plus z2 bar? And the answer is yes.